All right, these are the answers to the quiz review for 5154. The first few are just kind of just basic. Can we walk through and do the basics of this? So our derivative of 4e to the 3x, that's going to be 4 times derivative of e, which is its own derivative. That means we keep it the same. And then times the derivative of the exponent, which is 3. Okay. If we wanted to, we could make that 12e to the 3x by combining, but one or the other is going to be fine there. For number 2, we can pull that 6 out. We're going to have the integral of 1 over x dx. That integrates to natural log of x plus c. For 3, we're doing a derivative. This is a quotient rule, so we're going to take the bottom times the derivative of the top. Derivative of natural log of x is 1 over x, minus the top times the derivative of the bottom, which is 1 over the bottom squared. So you could cancel that if you wanted to make this 1 minus natural log of x over x squared. That works too. That's probably on a multiple choice what you'd have to get to, but both of those are correct. For number 4, we're integrating, and I've got e to the sine x. Now again, I can integrate e to the x or e to the u all day long, but if it's got anything more complicated than that, then I need to do u sub. So I'm going to make the sine x equal to the u. That means du is going to be cosine x dx, which means dx will be du over cosine x. So now you come over here, we got the integral of cosine x times e to the u times du over cosine x. Cosine x's cancel. So now we've got the integral of e to the u du. That integrates back to e to the u plus c. So if we do the substitution here at the end, we get e to the sine x plus c. Number 5, we're doing a derivative. This is a chain rule. Natural log is on the outside. Derivative of natural log is 1 over whatever's inside of it times the derivative of what's inside of it, which would be cosine. You can leave that, or if you wanted to slide the cosine on top, it could be cosine x over sine x, which technically is cotangent x. I don't know how crazy they'd get with that, but this is probably good enough right there. We get number 6, and I see that I've got quite a bit on the bottom top. I'm not going to do long division. That's if the top degree is bigger than the bottom. That's not what's happening here. Really need to think of this as a u sub at this point. So the u will be x squared plus 3x minus 1. The du will be 2x plus 3 dx, which means dx will equal du over 2x plus 3. Okay, now we bring that back over. I've got 20x plus 30. I can pull a 10 out of that, which will be important in just a second, over u times du over 2x plus 3. Now the 2x plus 3's drop, so that's not easy to see at first, but hopefully you got there. We pull that 10 out. I've got the integral of 1 over u du. That's going to become 10 times the natural log of the absolute value of u, which is x squared plus 3x minus 1 plus c. So that's our answer on that one. Number 7 is looking for a derivative. When you take the derivative of e, it's its own derivative. That means that that part's just going to stay the same. Keep the inside function here the same. So it just repeats times the derivative of that, which is negative 12x. These e's are easy. We just got to remember how they kind of work there. Number 8 wants us to do a derivative. This is a quotient rule again. And so we're going to take the bottom x to the 5th times the derivative of the top. Derivative of sine is cosine. Leave the 5x alone. Times the derivative of 5x, which is 5. Minus, so bottom times derivative of the top, minus top, sine 5x, times derivative of the bottom, which is 5x to the 4th. All over bottom squared. X to the 5th squared is x to the 10th. Now, at this point, you can leave this, or we could see this x to the 4th could get pulled out front. You'd have x cosine, well, really it's 5x, if I bring the 5 with it. Cosine 5x minus 5 sine 5x over x to the 10th. And then these 4 could cancel 4 of those. So we end up with 5x cosine 5x minus 5 sine 5x over x to the 6th. That's the simplest form for that, but whether you did that or not so important for this one. Number 9 is really a tough one. You got several different ideas that you might want to try. If you tried the entire bottom as the u, that's not such a bad idea, but you quickly kind of see that it gets really complicated with the derivative. Instead, you see that 1 plus e to the 4x is inside of this square root. So that's our u, 1 plus e to the 4x. And then du is going to be the derivative of this, which is e to the 4x times 4 dx. That means dx is du over 4e to the 4x. Come back over, we're integrating e to the 4x over square root of u times dx, which is du over 4e to the 4x. The e to the 4x's cancel, so I get 1/4 times the integral of 1 over square root of u. You got to be real careful here because the temptation is to try to make that a natural log. But if we rewrite it, it's just u to the negative 1/2. We can do a regular power rule on that. Add 1 to that, u to the 1/2 divided by 1/2, okay, plus c. If I flip this 1/2 over, I get 2 times 1/4. That becomes 1/2 times the square root of u, which is 1 plus e to the 4x, and then plus c. So I gotta be real tricky. What is u is hard on that one, and then making sure you integrate that also can be kind of tricky. So if you didn't get it right, that's okay, but then kind of look and see if that makes sense there. Number 10, I see I've got e to a kind of complicated exponent, so I'm going to do a u sub here. I'm going to x to the 5th be that u. Du then will be 5x to the 4th dx. So that means dx is equal to du over 5x to the 4th. So I come back over here. So it's going to be x to the 4th times e to the u times dx, which is du over 5x to the 4th. X to the 4ths cancel. I can pull that 1/5 out. I've got the integral of e to the u then. Integral of e to the u is just e to the u plus c. And then if I resubstitute in, I've got that right there. And then we get to 11. And we've got a lot going on with 11. I see this 1 plus 3 e to the 2x on the bottom. If I take the derivative of that, I get something like the top. So this is a u sub. The entire bottom is what's going to be our u. I don't want to just do this part because then I'll have 1 plus u and that'll be kind of odd. We'll just make the entire thing the u. So du is going to be 3 times derivative of e, which is its own derivative. Leave the exponent alone, times the derivative of the exponent, which is 2. So that means dx will be du over, and if I put that together, 6e to the 2x. So I bring it back over, I've got this 5e to the 2x over u times du over 6e to the 2x. E to the 2x is dropped. I can pull a 5/6 out. I've got the integral of 1 over u du then. That's going to give me 5/6 times the natural log of the absolute value of u, which I'm going to just replace with that, plus c. Now this technically is always positive. E to any power is positive, times 3 will be positive, plus 1 will be positive. So you don't have to have the absolute value on that, but it's not a bad idea in case you're not sure. That's part 1.